converting points, let's look at converting equations. So given this is in rectangular form. Let's convert this polar. So to convert it, we need to substitute. Instead of x, we're going to remember that x equals r cos theta, and y equals r sine theta. So now let's substitute. So I'll have r cosine theta plus 2 quantity squared plus r sine theta equals 4. Solve this. I'm going to have to FOIL this out. So when I square this, each one gets multiplied times itself. So I'll have r squared cosine squared theta plus 2 r cosine theta plus another 2 r cosine theta plus 4 plus r sine theta equals 4. Now I can see a couple things simplify right away. I can see that I can subtract 4 here, and I can also subtract 4 there for both sides. That cancels as well as that. Now I combine my like terms, and I'll have that r squared cosine squared theta plus 4r cosine theta plus r sine theta equals 0. One mistake I see I make is I did not square this term, so I need to square this here and here, which means this would be right at this point. It would be r squared sine squared. So I'm going to bring that down one more time. And now I'm going to do a weird little trick. I'm going to move this over here. So when I move this over, I'm going to have r squared cosine squared theta plus r squared sine squared theta equals negative 4r cosine theta. Now I'm going to do a little kind of a weird trick. I'm going to pull out the r squared, which is like reverse distribution. And so when I do that, I'm left with cosine squared theta plus sine squared theta. And that's going to equal over here. This side stays the same, so I'll just leave that over here in black. It's negative 4r cosine theta. Now, if you remember from earlier this year, cosine squared plus sine squared is equal to simply 1. So if I simplify that, I have r squared equals negative 4r cosine theta. Finally, last step, they both share an r, so I can divide both sides by r. And what happens is the r over here cancels, and one of these r's also cancel. So I'm left with r equals negative 4 cosine theta. So the graph in polar would look like this. It's a circle. So it's negative 4 cosine theta. Well, now let's think about this. This is a circle that's been shifted left 2. Let's go back to the start. This is in a circle form. This tells it to be shifted left 2. And the radius here is squared. The radius must be 2. Let's go back. The radius here needs to be 2. This is the center. It goes 1, 2 to the left, 1, 2 to the right. So this is correct. Here's another. This time you try to work it out, and then I'll pick back up with you. First step you're going to do is you're going to substitute in for the x and y with r cos and r sine. So you can go ahead and do that and see where you get from there. And now I want to pull out they both share an r, so I'd have 2r squared times cosine theta times sine theta. Now here's where this one gets tricky. The thing I'm assuming you probably saw is that you can divide both sides by 2. When I do that, these cancel. But what's a little tricky is the next step after I have this. From here, we're going to divide this over to the other side. And I will have 2 over cosine theta, sine theta. Now there's a double angle identity. It allows me to convert this if I take it back to the way it was with the 4 and the 2. So I actually shouldn't have changed it. It's kind of defeated the purpose. So I'm going to change this back to a 4 and this one to a 2. I know we could cancel those. I'm going to go back and not do so. Now what I've done here is a double angle identity. Now we didn't talk too much about this, so I wouldn't expect you just to get that trick. That's there. But what you could do is from here, if you have sine on the bottom, you know that's the same thing as C in the top. So we say that r squared equals 4 sine 2 theta, just like that. This is a graph of a hyperbola. Here's the graph here. It's hyperbola. I have one for you to try. You can pause the video. We know this should be a parabola. Let's see if you can get it in polar form. Here's what I did here. You can pause the video to get your work checked, but it was, in fact, parabola B.